Hey guys, and welcome back. Our next two guests on the Big Data Week online stage are two highly skilled and experienced engineers. They're working within a company that challenges the status quo in a very interesting niche of the fashion market. Let's welcome Diana Streche, the data engineer, and Horia Niculescu,
Hello.
data warehouse and BI cloud architect at Dormi. Their challenge was to go from survey answers to shopping recommendations and try before you buy in just a few seconds. They will share the magic way they solved it, how Horia likes to put it, and the architecture they used. They're not going to expect you to take their word for it, so they'll show you how to do it yourselves in a live demo. Guys, thank you for joining us. We're eager to see that magic happen, Horia. So let's roll.
Thank you, Matej. Thank you, Ola. So first of all, I want to thank everyone that's joining us on this technical track right now. Thanks for spending this time with me. What I wanted to do in this presentation is actually take the magic that we're doing behind. It's actually it's not anything mystical, right? It's really straightforward. We're taking the data coming from a streaming pipeline, so that's asynchronous communication, and then we're feeding it into a so-called data lake. Now, from there on, we will consume the data in a BI fashion. We won't go into heavy calculation and product recommendation, but what we'll see at the end is how we are feeding this data, heavy streams of data. Like, I think that we'll feed 10,000 rows in like a few minutes, and then see a BI report. So, with no further ado, I also prepared a small presentation as an intro to understand why we are standing here, right? So why Dormi, which is a fashion lingerie company, why we are standing here? So we're a lingerie company. We're a digital native brand from the United States, and although our headquarters are in New York, our IT power is here located in Bucharest. Hence, we were invited to the Bucharest Big Data Week. So what's Dormi about? Well, being a digital native brand means that we have a lot of emphasis on data-driven processes. So the company volume is like around 100 million. We actually aim for 150 million this year as of revenue, and then the technical and the digital aspects are rooted deep inside our brands. Like, we have our own warehouse, and the warehouse is actually full of robots.
I'm sorry to interrupt. Would you be so kind just to put the window down? Thank you very much. That was actually it. Thanks a lot.
Thanks also. So we have this. We also have some satellite brands, and we also push a lot for embrace like disrupt fashion, which is a sustainability movement that we've started. Okay, so that's Dormi, right? This is what we're doing. But we're not here for Dormi. We're here for the technical track. So let's go and see the technical part. Now, in data engineering, we see our work split into three main themes, right? There's the infrastructure, the code, and the data. Of course, there are a lot of other parts that a data engineer needs to handle. So the other parts would be data modeling, which is the intersection between code and data, the pipelines, the CI/CD, how we put that code and we build the infrastructure on demand. And of course, there is the developer experience and the user experience overall. Now, what we'll share of these streaming data pipelines is actually this part here, right? So we use infrastructure that is provided by Google Cloud Platform, and with some code, which we'll demo, we will pour data inside BigQuery. Cool. So how are we doing that? What's the use case here in Dormi? Well, we have applications, right? We have a ton of services, internal services that are developed by our IT teams. So of course, the casual application has a data repository, and then it communicates through various APIs, either via user interface or some calculation stuff, right? So that's the casual representation of an application. But then again, at Adormi, we have like tens of these so-called microservices. The so-called because some of are micro, some are just services, etc. But they all follow the same pattern, right? They communicate via API. They have their own database, which is isolated, and then their own admin and their own logic. So this is our production setup. But then again, we are not only sync, right? Because you will be synchronous communication when you ping an API and you want the result, then you'll take the synchronous data. What we are doing right now, in order to be to hold truth to the microservice paradigm, well, we actually are communicating data via asynchronous communication. So this means message brokers. In this case, this icon, of course, stands for RabbitMQ. You may have heard of Kafka, of PubSub, etc., but we're using RabbitMQ here. Okay, so we have a lot of services that are running with that are communicating via RabbitMQ, and then of course you need a gateway, right? What's outside the gateway needs authentication. What's behind it? Well, it's faster communication. But here we don't yet see the data warehouse. We don't see the data consumption. These are all apps. Of course, we have some other apps which are not behind the gateway, and then we have the data lake. So what we've said is, let's just try to pour all the data inside this data lake as to be the single point of contact, the single point of load. And then, of course, after the data lake, let's build our data warehouse, where we model the data, we normalize the data, etc., etc. And then, of course, build a plethora of applications and environments for our BI teams and for the data teams. And, of course, also put Looker on top. Looker is our BI tool. Cool. So how are we going to do that? Well, we have a swarm of RabbitMQ topics. And then what's the architecture that I will show you is actually for each of the topic from the RabbitMQ, we will have this PubSub, which is the solution offered by Google for asynchronous messaging, and then a cloud function, which will consume that data, and then it will put it inside the data lake, which is, of course, BigQuery. This is the icon for BigQuery, and from the data lake inside the data warehouse. And the cherry on top for this demo would actually be the Data Studio, which is the BI solution offered by Google. Okay, so with no further ado, we will have a Q&A session at the end. But what I want to do right now is build this whole thing from scratch in under 10 minutes, while also telling you what I'm doing and how we're going about it. Okay, so if I'm going to exit the presentation, it has served its purpose. And then what we're going to need? Well, first, we are going to need this. Let me copy paste this. So we are going to need a topic, right? A topic is like a Slack channel or a group for WhatsApp. We will delete this topic, delete. And I will try to create everything from scratch, right? So we don't have any topics here. I will just go create a topic. Create a topic. So that wasn't hard, right? Of course, we also have the Google client, the SDK, and there are also Python libraries, Java, Go libraries. But in this case, I just want to do it by hand because I want to show it how easy it is for semi-technical users. So we are right now creating a topic. It usually takes like about 1 minute. And it will be created. Then what we'll also be doing, I will cancel this script. This script was actually pushing a lot of data on that topic, like 15,000 messages already. Okay, so we have this topic right now. It's going on. We won't build any subscription right now. What we also want is to build a cloud function, right? On this topic right here, we could click here, trigger a cloud function, and we could do it by hand. But I don't want to do that. I want to go a bit more in detail. So the cloud function, I will just delete this. We don't have any cloud function, so let's see how we build a cloud function. This should take us less than 5 minutes. So in order to build a cloud function, this is our repo right now, right? Let's just forget about this. This is the repo right now. We have Big Data Week, and we have like 2 modules. We're going to run this in Python, of course. And this is the module that we want, load order feedback. What a cloud function actually needs are 2 files. It actually creates a Flask API behind it. So in order for this Flask API to communicate with the outside world, it needs an interface. And that interface is provided by this main.py file. And this is the entry point. Of course, when we will build it, when we will build this cloud function, we also need to mention the requirements. In this case, we will only need one external library, which would be Google BigQuery, Google Cloud BigQuery, and everything else that we will use in main.py, like the JSON, base64, etc. We will already have it as the default package from Python. Cool. So let's see how we would do this. Well, first, of course, we need a function, right? So this function will serve as the API entry point. And this function, this actually is dictated by Google. We need an event and a context. The message that we will publish on this PubSub, right? So let me publish a message, any message here. I will just say, hello world. Hello world. This message won't go anywhere. It will just sit here on this topic, do nothing. Why? Because we're not yet consuming it. We don't have neither a subscription nor a cloud function that will create this subscription. So it will just stay there. This body of message that we just published here, it will be wrapped in this event dictionary, and it will be passed down to this cloud function. Then Google, what we will do, it will also decorate our message with context, which was the service, when it was triggered, etc., etc. So what we're going to do right now, we are actually going to try to extract from this event. Of course, it's a dict, so we're using the get method, and we will extract the data. This is where our body of message resides, right? Again, publish a single message. I'm writing something here. This will be wrapped around the data object. Now, this being an international service, it's a best practice to be encoded, right? So then, of course, we need to decode it back to UTF-8. So we are also decoding it. And then that's the secret. Well, what we want to do right now, we want to post a JSON, right? And the JSON would be like this one over here. We've said that we will serve an example of feedback. So we have an order, and then of course we will have a customer, and then we will have a quiz, some questions. So for each product that were on that order, which is a panty, a bra, a corset, we will have a rating and a comment. So this is our JSON structure. What we'll be trying to do, we won't try to insert this thing into BigQuery per se, but we will stringify it, and we'll just insert into BigQuery two columns. The data column, which will be this stringified text string, and loaded that. Okay, where were you? You were here. So we are stringified, we're cleaning it up here, we're removing any unnecessary. Unfortunately, this is a mandatory step, because with all this going into JSON, going into JSON again, we will add some extra characters that we want to eliminate, and then this is where the magic happens. What we need to do, so until here, we only received, in our API, we only received a text or 2 dictionaries, and we played with some strings. What we want to do here, well, we want to initialize the BigQuery client, which we already imported up here. And then we want to initialize our object, right? So our object is project, dataset, and table. and run the job. That's it. Of course, we just threw an exception over here. So this is the cloud function. Again, what we're doing, we're receiving a dictionary, we're extracting the data, we're cleaning the data, stringify it, and then passing it to BigQuery. Okay, so let's see how the BigQuery setup looks like. So in BigQuery, I will drop all the tables. The cloud function, the tables, the views, everything that I've done. Not found. Oh, that I already dropped. So what we're going to do, we're going to create a simple, very simple basic table, right? So this basic table looks like this. It has a data column, which is a string, and the loaded at, which is a string. Well, actually, this could have been a timestamp or a date or something, but let's just call it a string for the moment. And if you're going to run a select star over it, of course, it will be empty. Cool. So if it's empty, let's just publish a message and see what happens. Well, I will just take this message over here. I will publish it first by hand, and then we will use, we will start the script that's pushing the messages. So I will just publish it. And the cloud function should run. Oh, I don't have a cloud function. Yeah, let's deploy it. So currently we don't have a cloud function. We want to deploy this into Google Cloud. Well, we could have used Cloud Build, we could have used a lot of things, but I will just use PowerShell. And I will use the SDK, the G-Cloud client, and I will deploy my function. Usually this takes up to 2 minutes, but I don't think that we'll wait more than 1 minute for it to be deployed. Once our cloud function is deployed, any message that we will post on the pub subtopic will automatically be consumed, and based on the options that we have here, also acknowledged from the pub subtopic. Cool. Now, even if it's fun to see this loading, let's go back to BigQuery and see what we're doing. So what we will be doing, we will see like 2 columns, data and the timestamp. But then again, we also want to consume that data, right? We wanted to have it in a table format for us to run simple SQLs for our data analysts, for our business analysts, to be able to use it. So what we are actually doing, and this is where the magic happens, the actual magic happens, is we're going to create a user-defined function that will break our JSON, will break our string into a JSON, into an object, and that object will, of course, be available in table format. So let's just create this function over here. Function is written in JavaScript, but actually doesn't have anything, of course, except the JSON parse. So that's the single thing that we're using from there. BigQuery also has some powerful run selected. Also has some powerful JSON functions, but in this case, this is the simplest way to decode the data that we've found so far. Let's see if our cloud function knows such file in pub/sub. Oh yeah, we're not in the correct directory. Yeah. Okay, let's go again. So after we created this function to decode our message, what we will have is actually this. So of course, BigQuery has CTE, and this allows us to play with widths and subqueries. So what we're actually doing, we're applying our user-defined function over the string of the data column. We will just delete this limit 5 over here. We don't want it. And we want to create an object. So we will write a create or replace view. Let's just give it a name as the thing below. The view, we will create it like this, like it's a view, and this should be nested. Let's see if it works. Run. Okay, it created it. And now what we actually did, We have a nested object. It's a record repeated object that has the order ID, customer ID, quiz, and under the quiz, it has repeated records. Let's see. So yeah, this actually was deployed and it should be working. So time for demo. First, we will take this message by hand and we will publish it, and then we will see what is going on here. Publish message, publish single message, publish. So what's going on here is, come on, just go away, go away. Okay. Now this call function is available. This call function is consuming our data. Is this one over here? Of course, we're using the Python 3.7 environment. These are my previous loads, like almost 5 messages consumed per second. And now we should check our import table to see if by magic our data has appeared. Yay! So our data has appeared, and as you see here, it is a string. We don't want to apply regex or anything like that. So when we're actually querying our view over here, let's write a select start from. Never do a select start from in BigQuery, okay? We're just doing this for demo purposes. Like BigQuery will what's that? Create or replace. We haven't created it. Oh, create or replace. Okay, and now we should be able to. Oh, we don't. Okay, this is a demo. We didn't want to query the function. We wanted to query the view. So I'm sorry for that. Now, when we're querying this view, we'll see the data in a nested format. Yay! Now, we have this in nested, but then again, we also can create, if we don't have power users that can actually consume the data in nested format, we will flatten it by using the unnest function, whoop, and we will query it again. Okay, so this is our flat version of that object. So far, so good, but where's the magic? How are our messages actually pouring through all this setup and how powerful it is? Well, let's just check it out. So we've seen how it managed one message. What I'm doing here in feed, I'm just using the random choice. So I'm just creating some random messages, right? This would be our product types. This would be the choices, the rating from 1 to 5, and this would be like some text, something. So let's just try to insert. Oh, and I'm also using a sleep here. Let's just sleep here for like 0.2 seconds. Save. Okay. So right now, data is starting pouring through our pipeline, right? So we already have 50 messages, 60, 70 messages, etc. Our clients are rating our products and are rating our orders like crazy. Let's see how BigQuery is actually doing, right? So remember that this flat view over here needs to break down the string, break down the nested, and flatten everything. So what we'll be doing here, we're actually going to run once. So we have 280 right now, 322, 300. So this means that BigQuery right now, even if it's a columnar database and it's a data warehouse provided by Google, it can do streaming data and it can do it like pretty well. But what should we do from here? Well, we could consume data with our data apps on top of BigQuery. That's something that we could do, but what I would like to do is actually see like BI, right? Real-time analytics. So in real-time analytics, what I will try to do is create a data studio, right? It has a lot of connectors over here, but we will use the BigQuery connector. Here we have a lot of projects, but we're actually interested in one project, Big Data Week. Yeah, this is the one. And that's an interesting thing. What we'll try to do, we'll try to do dashboards on top of nested data. Not a lot of tools can do that. It's a feature that most tools are integrating right now or have integrated in the last like couple of months. So what we're actually doing here, do we like this table? Nah. Okay, so I will delete this table and I will try to add a chart. No, let's do a pivot table. Okay, so in our pivot table, what it's doing actually right now, it's querying the view and it's fetching the data for us. Does it look nice? Yeah, why not? So we have various answers to our products. What should we do? Oh yeah, we should add this icon over here. Okay. Is it adore me now? We need to put this logo here. Yes, perfect. So now it's ready for our colleagues to consume the report. Boom. Let's just view it. Okay, so these are our results, right? So what are we trying to do? Well, 5 minutes have passed. We want some refresh data to take some decisions. We will just refresh the data. So 30, 20, 29. Now it's 40, 38, 45. So when we hit the refresh data, poof, all of our BI solutions, well, in this case, it's Data Studio, but you can do this also with Looker. Looker also is able to play with nested data. If you don't want to play with nested data, then you'll go back in BigQuery and you'll just run your queries and run your analysis on this flat table. So that's the magic that I want to debuckle and I wanted to demystify. What we're actually doing here at Adore Me, well, we're using this kind of cloud function to move the data from an asynchronous PubSub QS or RabbitMQS universe to be able to play with it in SQL. And with SQL, a lot of more analysts, BI, and data people could access it and could harness the information live. So with this, I will close my demo. I will stop sharing my screen. Stop sharing.
Horia.
Yes.
That was quite nice, and we did manage to make the time. So it's really quick demo of how quickly we can pull some data in through the solution. So we're officially going to open up to our Q&A session. You are invited to add your questions into the My Connector platform. So while we wait for the questions to pour in, I'm going to open up a few extra topics. Now, you showcased this over Cloud Functions over BigQuery. Why BigQuery? Why can't we not add it in cloud storage, for example, or can we use any other storage method for this?
Yeah, that's a really good question. Thank you, Diana. Well, actually, once we loaded the data in memory, right? So we load the data in memory in Python and bam, we have it there. We just need to write it somewhere. So where should we write that data? Well, we chose to write it in BigQuery. You could write it in Firestore, in Data Store, in MySQL, in Cloud SQL, anywhere you want. Now, why BigQuery? Well, because it serves us well as a data lake. Why? Because first, you've seen that you could put there anything, right? Strings. It could be CSVs, YAMLs, JSONs, any kind of format, and it just sits there. That's first, right? So you can ingest it. Second, because you can consume it really easy. You can consume it with SQL skills, which a lot of people have, while going in some other database, it's harder to implement and to have access to.
Okay. One other question that we usually get, and particularly in this context of the cloud, and particularly Google Cloud Platform, what kind of costs and limitations are we looking at? What kind of input output are we expected to have for this kind of solution for it to make sense for us?
Mm-hmm. Yeah, that's a really good question, because this architecture is not suitable for all use cases. What we've done here, we've seen like 10 messages per second pouring through. For a casual website, I don't think that you'll get that many reviews, that high volume. If you get higher volume than that, for sure, this whole setup is standing. How far will it stand? Well, let's just say that we have the maximum concurrent invocation for a single function up to 3,000. So we've seen that with 10 invocations per second, it was blazing through. 3,000 is quite high, but that shows it's extendable. So that's the number of invocations. Then what about the other things? Like, okay, but you're taking the data in memory, right? We're taking a JSON in memory, and then we're just cleaning it up, making it tidy, nice to be put into BigQuery. Well, that's the thing. First, that cloud function has a maximum timeout of 9 minutes, but we're now talking in seconds. So that's not a limit. Then again, we have another thing, which is 264 megabytes of memory. So nobody would be crazy enough to send, like 1 megabyte, a JSON that big, like 1 megabyte of JSON. And even so, you would have space for 200 plus cloud functions running in parallel. But even so, you have that. So it wouldn't be a limitation of size. And then the costs, well, that's the thing. The costs are directly linked with the volume and the stress that you put on top of the cloud functions. Now, what's happening behind the scenes? We've said that the cloud function is building a Flask API with which you can interact. But then again, what's behind the API? Well, it's a cloud. What's that? It's a compute engine instance. So that's basically a VM. So you're paying the service for the cloud function, and you're paying the uptime of those VMs. And you're asking, yeah, but what kind of VMs do you have in the background? Well, it depends, because Google may switch them, so that depends on the setup of that given instance.
One of the biggest advantages of this is that it is actually scalable. So up to a certain limit, you don't need to worry about how many messages you're sending, because it will just spin up and spin up and spin up resources until it can deliver the output. However, there's the fallback of cost, and if you don't want to run too much of a cost, it's best to put in place some limits, some tiers to your pricing, so that you don't end up having financial accidents.
Yeah, that's a good note. Why? Because previous to using this cloud function, we also used like two other, or a lot of other, but two main themes. First, we opened up some VMs, and then we had a supervisor running, and with that supervisor, we were actually providing the infrastructure, and we were doing this kind of Python-esque scripting, and we were pulling with our left hand and placing it with our right hand. And then we've said, no, this is not scalable. We need to open VMs by hand, or even we use Terraform or something to orchestrate the infrastructure. We don't want to orchestrate the infrastructure. We are willing to pay for that. So, okay, what should we do? Well, let's just use data flow, right? And Google actually allows us to use data flow. Data flow is the runner of Apache Beam provided by Google, and those have instances and templates. Just click, click, and bam, you have your data pipeline. But those were kind of expensive, like $50 per month per one instance. So if you have like 100 instances, what should you do? Like $5,000 for what, when you could run cloud functions, is not big, right, in the grand scheme of things. But still, you shouldn't pay for that if you have other options. We search for that option, and now we have these cloud functions which are incomparable to cost with the other things.
It really depends on the scale of the business solution and whether or not it is profitable to go for a data flow versus a cloud function according to the kind of volume of data that you have.
Totally.
Now, another thing that I think our audience will find particularly interesting to talk about is the data studio over nested data. Now, this it's pretty new, so I've only, like you, seen it in a handful of tools. So maybe we could give them a bit more detail on that and how easy it is to use.
Okay. So first of all, why use nested data, right? When space and hard drive space storage is like so cheap, why look at using nested data? Well, first of all, because of space. Even if it's cheap, you don't need to use it. That's first. Second, because nested data actually allows you to embed logic in your objects, right? Most developers are already very accustomed to JSONs, and that JSON actually allows you to link the keys between themselves, like we've done here, right? We have the link for an order, which had an order ID, and then that order actually had multiple products and multiple quizzes. So from a data modeling point of view, those are two entities, right? You have a quiz with an ID, with some questions, etc., and then you have the order, which is another entity. Using nested format, you can unload the pressure of the analyst to do the join. Take the orders, join the quizzes, build a nice object. In this case, it was really simple because we chose this example for the demo. But what happens if you want to join orders, transactions, right? Because you have some payments attached, you have a shipment to an order, you have some returns, you have customer attributes, you have products, you have promotions, and then you also might have some coupons. Just think of, I already listed like 8 entities which would need like at least 8 joins. If you would do a nested table, you would have one object and you would go like grocery shopping. I want something from the transactions, I want something from orders and something from customers without actually needing to check for logical keys in order to join them.
It also makes a lot more sense in terms of processing power, because the data, when it's in nested format, it's stored around the same cluster. So BigQuery doesn't have to go searching through various locations for the data. If you want it, it can just fetch it for you. It doesn't need to pull a separate search up through a join into a different table. So we're approaching the end of our session. So I would like to thank everyone for joining us, and I hope this was insightful for you. Feel free to reach out to us if you have any questions after the conference. And I wish you all a pleasant evening.
Thank you very much, guys. We'll see you in the next session when we'll talk with Andras Palfi. So see you guys over there.
Thank you a lot. Hopefully this was insightful. Ciao. Bye.